In this video, I'm going to talk to you about solving quadratic equations by factorising. This is one of three methods for solving quadratic equations. The other two are using the quadratic formula and completing the square. Now, solving quadratic equations by factorising requires you to be able to factorise quadratic expressions. And if you're not sure how to do that, have a search on revisemaths.org.uk for factorising quadratic expressions, and there's an explanation for you there. I'm going to do a little bit of that now anyway. So here we go. Here is a quadratic equation. We know it's quadratic because it's got an x squared as the highest power of x. So x squared plus 6x plus 5 and equals 0. We can only solve quadratic equations when they're equal to 0. So we start off by taking our two brackets, and we're going to factorise this equation into those two brackets. So we've got an x squared at the front, that means we've got an x in each bracket. Then we look at the number at the end, the 5. 5 is a prime number, so there are only two factors. They are 5 and 1, our only options. Both the signs are positive, so both the signs in the brackets will be positive. Now we factorised our equation, so x plus 5 multiplied by x plus 1 equals 0. Now in order to solve this equation, we've got to think about how we make this equal to 0. Now in order for this whole left hand side to equal 0, either the x plus 5 bracket has to equal 0, or the x plus 1 bracket has to equal 0. So this gives us two linear equations. So we have either x plus 5 is equal to 0, or we have x plus 1 is equal to 0. So if we take each of these in turn, so if x plus 5 equals 0, take 5 away from both sides, and we get x equals negative 5. And over here, x plus 1 equals 0, take 1 away from both sides, we get x equals negative 1. And those are our two solutions. We have x equals minus 5 and x equals minus 1. Now, solving quadratic equations by factorising is fairly straightforward. As you can see, 4 equations that will factorise easily. Some equations won't factorise, and that's when you need to use one of the other methods, such as using the quadratic formula. Now when you've got your solutions, x equals minus 5 and x equals minus 1, sometimes you'll find there are two solutions. Sometimes you'll find there is one solution, and there are some quadratic equations which don't have any real solutions, and you definitely wouldn't be able to factorise those. Now let's have a think about this for a minute. A quadratic equation like this can be represented on a graph. Here is a graph of the equation y equals x squared plus 6x plus 5. So that's the same as we've got over here, x squared plus 6x plus 5, and this is equal to y. Now, over here our equation was equal to 0. So in order to find the solutions on the graph, we've got to look at when y equals 0. Now y equals 0, we go down the y-axis here along the x-axis. So the points at which our curve, which is what we get when we plot a quadratic equation, the points at which that crosses the x-axis, where y equals 0, are our two solutions. So you can see that we've got a solution here, it crosses at x equals negative 5, and it crosses over here at x equals negative 1, which matches up with what we had from our solutions over here. Here's another quadratic equation. Let's have a go at factorising this one. So we have our two brackets, which are equal to 0. We've got an x squared, so that means x at the front of each bracket. We look at our signs now. We've got one negative and one positive. Now because we've got a positive here, they've both got to be the same. Because we've got a negative here, they've both got to be negative. So two negatives there. Now we need factors of 9, and the factors of 9 are either 1 and 9 and 3 and 3, but only 3 and 3 will give us 6. So we have 3 and 3. Now if you look at these two brackets, they're both the same. So we could write this as x minus 3 all squared equals 0, because we've got x minus 3 multiplied by x minus 3, which is x minus 3 all squared. Now when we have a situation like this, what we're saying is that both of the solutions to the equation are the same. So we only have one case, and that is when x minus 3 is equal 0. So that means that x will equal plus 3, and that will be the only solution for our equation. And if we have a look at this on our graph here, we can see that our quadratic curve, when we plot it, doesn't cross over the x-axis, it only touches the x-axis. So it touches at the point 3, because we only have one solution, that's when x equals 3. This final example is slightly more complicated, because instead of having 1x squared, we now have 12x squared. And then we've got minus 28x, and that's equal to minus 15. Now remember, we can only solve an equation like this when it's in the form ax squared plus bx plus c equals 0. Now at the moment, our equation isn't equal to 0. So the first thing we have to do is rearrange it so that it is. And we're going to rearrange it by adding 15 to both sides. So we'll end up with 12x squared minus 28x plus 15 equals 0. Now we've got a quadratic we can solve. We're going to have a go at factorising it. So we need our two brackets, and we need to first look at our number in front of the x squared, the coefficient of x squared, and that's 12. Now we know there are factors of 12. Those factors are 1 and 12, 2 and 6, and 3 and 4. But we also need to look at the factors of the number at the end, the 15. The factors of 15 are 1 and 15, and 3 and 5. Now we're looking to see which pair of factors of 12 and which pair of factors of 15 will give us 28. Now to help us out, we can spot that because we've got a negative here and a positive here, we're going to have two negatives in our brackets. So we're looking for numbers that are going to add to make 28. And if we look closely at that, we'll see that the solutions we want involve 2 and 6 and 3 and 5. So if we have in the bracket here 6x in the first one and 2x in the second one, in order to get 28 we need to multiply the 6 by 3, so that goes in this bracket, and the 2 by 5, so that goes in this bracket. Now let me just show you how that works. Let's multiply it out. So we've got 6x times 2x gives me 12x squared. Then I've got 6x times negative 3, which is negative 18x. Then I've got negative 5 times 2x, which is negative 10x. And then I've got negative 5 times negative 3, which is positive 15. And if I simplify that, I get 12x squared minus 28x plus 15. So we got it right. So now we've factorised this, we have our two linear expressions. So we have 6x minus 5 equals 0. The other one is 2x minus 3 equals 0. So you can see these are slightly more complicated than the previous examples, but exactly the same principle. We now need to solve these linear equations to find the values of x. So over here we start by adding 5 to both sides. That gives us 6x equals 5, and then we divide both sides by 6, which gives us x equals 5/6. And the second equation, we start by adding 3 to both sides, which gives us 2x equals 3, and then we divide both sides by 2. So we get x equals 3/2, or 1.5. Now you can either leave those like that, or you could convert them into decimals on your calculator. Now if we just have a very quick look at that as a graph, we can see that when we plot this, we end up with 2 solutions, and that one there is the 5/6, and this one is the 3/2, or the 1.5.